Hello, I'm AJ Garrett with Robertson Heating Supply. Robertson's has an engineering and technical department that is here to help you with any kind of application, design, and troubleshooting. Today, we're going to go through finding the heat loss and heat gain of a home. Then we're going to put that heat loss and heat gain and decide which application or which furnace size and which air conditioner size is best for our application. Let's get into it. On this side, we're going to look at the heat loss of the house. The heat loss of the house is that whenever it gets colder outside, the house starts to lose heat. We need to replace that heat in the house and add more heat to it, and that's where the furnace comes in. So on this graph, we actually have on the horizontal line is that we start about 65 degrees Fahrenheit and we come back down to about -5 degrees Fahrenheit. This is for our application in our territory. The heat loss on the vertical side is going to say 0 BTUs all the way up to 70,000 BTUs. Again, this is the only use for our application. Depending on the size and needs of the house, this 70,000 BTUs could go as high as 100, 200,000 BTUs. But for today's purposes, we'll use 70,000. We have a diagonal line that comes across here. On this diagonal, it represents how much heat the house requires at any given temperature. So we'll plot which our house needs right here. In our example, we're going to take a 1,900 square foot house. And we're going to say that house, to maintain 72 degrees Fahrenheit inside, it actually requires 62,000 BTUs of heat when it is 8 degrees Fahrenheit outside. So let's chart this. 62,000 BTUs of heat we come across where it intersects that diagonal line. We're going to plot down and see that equals 8 degrees Fahrenheit. However, manufacturers of equipment, they don't exactly size or make equipment to your specific size for your house. Okay? They typically start at about 40,000, maybe a 60,000, a 70,000 BTU furnace, all the way up to 100, 120,000 BTUs. So we need to make sure we size the equipment properly and choose the correct size furnace for our application. Today we're gonna just pick a 95% gas furnace that is 70,000 BTUs input. So we're putting 70,000 BTUs into the furnace, and that's what the gas is actually burning. It is 95% efficient. So we're actually getting 66,500 BTUs of output. That is the heat that is actually going to go into the house to heat the house up. So let's plot this out on our chart. So we find the 66,500 we come across, plotted on our red line right here. And we find that 66,500, drawing a straight axis down, will heat the house up when it's approximately 4 degrees outside. So we know we have actually covered our 62,000 BTUs at 8 degrees Fahrenheit. Why do we choose 8 degrees Fahrenheit? Well, different territories require different design temperatures outside. If you live more in the south, this design temperature could be a little warmer. But if you live northern, this design temperature could actually come down a little bit, maybe 0 degrees, maybe even colder. So we've chose the 8 degrees Fahrenheit for my territory. All right, so the 66,500 we learned will cover us when it is 4 degrees outside. We've sized this equipment properly. We're going to maintain 72 degrees Fahrenheit inside that house anytime that it is 4 degrees outside. Now, for comfort and application, maybe we want to pick a better furnace. So we look at like a 2-stage gas furnace. A 2-stage gas furnace, well, how does that work? Well, our stage 2 is going to be our full load or our high stage. That is all 70,000 BTUs going in. So if we pick a 2-stage gas furnace, stage 1 will actually be only about 70% of the total input. So we take the total input, We take 70% from it, we come out with a 49,000 BTU input on stage 1. It's a lower stage. It's still 95% efficiency, so we're going to be putting 46,500 BTUs into the house on stage 1. Let's plot this one out. So 46,000 BTUs, we come across where it intersects the diagonal line, we drop straight down, and we find at 25 degrees, stage 1 will satisfy the house. So anything really in this block right here, stage 1 will take care of. Should we start to get outside of that block, we now require stage 2. Anything that's within the red block. Now, if we step out even further from the red block, it doesn't mean that the furnace isn't going to work. It just means that the furnace may not maintain 72 in the house. We're still going to be putting heat into the home, but on days where it gets down to -5 degrees, the indoor temperature might only be 67. As it warms back up, the temperature will come back up in the house. We want to make sure we size the equipment for comfort, for efficiency, also for energy demands and stuff. We don't want to size the equipment that maybe costs too much to run. So we feel that a 70,000 BTU furnace fits our application perfect here. Let's step on over to the cooling side. Okay, now we're going to take our same application and we're going to look at how much the heat gain is of this home, and we're going to decide what size cooling air conditioner we need to satisfy. So we have a similar chart over here, and we actually start at about 60 degrees Fahrenheit outside, and we go up in temperature on the outdoor to about 90. Again, this temperature can vary depending on your design application. On this side, on the vertical, we're actually going to look at 0 BTUs, and it'll go up to about 36,000 BTUs. Again, this is for my application design for the home that we're looking at. Now, this can go up to 48,000 BTUs or 60,000 BTUs. Again, depending on what you are sizing to. So, what do we have? We have the same house, 1,900 square feet. This house, we have determined, takes 2.5 tons to cool it down when it is 85 degrees outside. We're going to maintain that 72 inside because that's the homeowner's comfort level. So we find a 13 degree temperature difference from outdoor temperature to indoor temperature is what we are going to maintain with 2.5 tons on this application. Now, every air conditioner is rated in tons. Tons to equate to BTUs. There is 12,000 BTUs in 1 ton of cooling. So if you take 12,000 times 2.5 tons, that equals 30,000 BTUs of cooling is required. So let's go plot this on our chart. We find 30,000 BTUs. We come across to our diagonal line. We drop down to 85 and we build our box, and that's where our line charts out at. So we know at a full load, at 85 degrees outside, our house is going to maintain 72. Now what we need to take into effect is that there are other things besides outdoor temperature that maybe make a difference on what size cooling unit we choose. There are things called internal heat gains. Internal heat gains can either be anything from lights to people, pets, to even ovens and hot showers and anything else like computers and TVs. So we have decided that with all our internal heat gain and with our outdoor temperature, that 2.5 ton is going to perfectly fit our application. It's important to know though, anytime the temperature goes above 85, we may not satisfy the house at 72. Again, we're designed around to 13 degrees from outdoors to indoors. So when it becomes maybe 90 degrees outside, we may only satisfy to 76, 77 degrees inside if we're over design temperature. Now your design temperature again depends on the area you're at. If you're in the south, the design temperature may be higher, okay, than 85, or if you're in the north, that could be slightly less. But we also have to take into effect dehumidification which is for a different topic. Now, if we want to get a better piece of cooling equipment in here, and we want to choose maybe a two-stage air conditioner. How does a two-stage air conditioner work? Well, you still have your full load, which is stage 2, and that's our 30,000 BTUs. But on days where it's maybe 75 to 80, we don't need to run that air conditioner on full stage and use as much electricity. So we'll drop it down to stage 1. And stage 1 we find on this specific air conditioner is 21,000 BTUs. When we come across the 21,000 BTUs, we drop down and we learn that, hey, at 78 degrees outside, or 77, right around there, we're going to cool the house just fine. That includes our internal heat gains as well as the outdoor temperature. Now, anything in this box right here, we are going to cool with first stage. When we get from about 77 to 85 outside, we are actually going to cool that house using full load, which is stage 2, 30,000 BTUs. And again, like we talked earlier, anything that gets hotter than that outside, we're still going to cool the house down. We just may not cool it down to 72 anymore when it gets above 85. This is a good starting point on design and application. Should you have any questions, feel free to reach out to our engineering team. Call 330-821-9180. We'll be glad to help with any kind of application, design, or troubleshooting needs. Thank you.